you'll learn about APIs with a specific focus on SOAP and RESTful APIs. API stands for Application Programming Interface. It's a way for a computer program to communicate directly with another computer programming. So in networking, if you're using the command line to work on a network device, that's not using an API because that is human to machine interaction. An API is used when it's direct communication between software to other software. APIs are typically used to perform CRUD operations. CRUD stands for Create, Read, Update, and Delete. I'll talk about that more on the next slide. And the two main types of APIs for web services, meaning they can run over the internet and typically use HTTP or HTTPS, are SOAP and REST. Netconf and RESTconf are other APIs, which are specifically designed to work with network devices. I'll speak about those more in another lecture later in this section. So those CRUD operations, it stands for Create, Read, Update, and Delete. This actually originates in the database world, which is why you can see the first example here is SQL, which is commonly used for databases. So if you were working with a SQL database and you wanted to create a record, you would use an insert command for that. If you wanted to read, you would use select. To update would be update, and to delete would be delete. We can also use HTTP or HTTPS for our CRUD operations as well. So with HTTP, if you want to push some information to the server side, if you want to create something, you use put or post as the HTTP method. If you want to read information, you use get. If you want to update, that's a put, post, or patch. And to delete, you use the delete method. So with these, because they're doing words, you can also hear these being described as an HTTP verb. They're either going to be called an HTTP verb or an HTTP method. Means the same thing. And if you're wondering, well, if I want to push some information over HTTP, if I want to create something, do I use put or post? Well, it depends on the particular application, the particular system that you're working with. So check the documentation and it will tell you there whether it expects a put or a post. It's going to be one or the other. So we can use HTTP and HTTPS to do these different operations on the system that we are interacting with. Okay, our first API that we're going to look at here is SOAP. Stands for Simple Object Access Protocol. It's a standard communication protocol that permits processes using different operating systems like Linux and Windows to communicate. The transport is typically HTTP or HTTPS. The data format is always XML. So with SOAP, it is a protocol. So it specifies exactly how it should work. It's got strict standards to adhere to. One of those standards is that the data format has to be XML. The transport can be anything, but typically it's going to be HTTP or HTTPS, which is used. Okay, the other API main one for web-based services is REST. This is super popular now. REST is an architecture, not a protocol, unlike SOAP. It gives guidelines for the structure and organization of an API. So because it's an architecture, not a protocol, it doesn't say you have to do it exactly like this. It's got guidelines for how it should be done. Because it's not as strict as SOAP, it supports any transport and any data format as well. HTTP and HTTPS are most commonly used for the transport, and JSON or possibly XML data formats are commonly used. It's typically got faster performance and it's easier to work with than SOAP. So with modern web-based APIs, you'll see that RESTful APIs are by far the most commonly used now. So it's an architecture. It doesn't say exactly how REST should work for each particular application, but it does have guidelines. It does have constraints there. So there's constraints about what qualifies as a RESTful API. First one is it should be a client-server architecture. The client sends a request, the server sends a response. So if you're using an API to interact with a network device, such as a router, then the router is the server and the client software is the client. It must have a uniform, standardized interface to provide simplicity, and it must be stateless, meaning that no client context is stored on the server between requests. So every time the client sends a request to the server, that is a completely independent, self-contained request. So some example implications of this. If the client has to authenticate to the server for security, which is very common, it's going to need to authenticate in every request. It's not like the client first authenticates and then it can communicate after that using those credentials, because the server does not store that information. It's stateless. So each command, each request has to be self-contained. If you are using authentication, the credentials have to be sent each time in each request. Next constraint is cacheability. Responses must define themselves as either cacheable or non-cacheable. So the constraint is that it supports caching. So for example, if you were using a GET request to get information about the interfaces on a router, well, that information is not likely to change very often. Your physical interfaces on a router are pretty fixed. So the server could tell the client to cache that information. It doesn't have to keep checking that it hasn't changed frequently. More constraints must be a layered system. So any intermediary devices between the client and server, such as load balancers, must be transparent to the client and server. And it needs to support, well, it optionally supports code on demand, where servers can temporarily extend or customize the functionality of a client by transferring executable code. Okay, so those are the requirements for an API to be classified as a RESTful API. But as I was saying, RESTful APIs are by far the most popular now. So if a particular vendor has got an API which doesn't actually comply with all of these constraints, you'll still see them often describe it as a RESTful API anyway, as long as it complies with most of them. Okay, looking at the format of a REST request. So as I was saying, this is typically going to run over HTTP or HTTPS. So for the client to communicate with the server, it needs to be able to get to the server. It gets to the server based on the server's URL. So the format of the URL is it's going to be either HTTP or HTTPS. And then there is the server, the target host that it wants to communicate with. And then there's going to be the resource that it is interacting with on the server. And it depends on the particular application, what the exact format of this is going to be. As an example, /API, /running, /AAA, /users, /nil. So in this example, I'm interacting with an authentication system for AAA. And then optionally, you can have a query string with parameters on the end. So in the example here, this would be used, for example, if I am putting some information on a AAA server, if I'm altering the parameters, the characteristics for this AAA user of Neil. And here I'm using a parameter of dry run, saying I'm just going to do a dry run here. Don't actually make the changes, just check that it is going to work first. So we've got the URL that we are interacting with. Other information that has to be sent with the request includes the request method, the HTTP method. So is it a GET, is it a POST, etc. Also, typically, headers will be included as well. They're optional, but they'll often be there. This is key value information about the request. For example, headers here, except application JSON means that in the response, you're expecting that to be formatted with JSON. Other things that could be included in the header are your authentication credentials. And if you're pushing information to the server with a post, a put, or a patch, then the information that is going to be getting pushed to the server is going to be included in the body of that request. Okay, so with our RESTful API, we are going to be sending requests to the server for those CRUD operations. The server is then going to respond back. With the response, it's also going to have a header, a body, very similar to the request. It's also going to have a response code there. Anything, this is going to be a 3-digit code. Anything beginning with a 1 is an informational response. Anything beginning with a 2 indicates that the request was successful. So for example, it could be a 200 OK message. If we were pushing some content onto the server side, it could respond back with 201, saying that yes, it has been created successfully. If we deleted something, then we would get a response code back typically of 204, meaning no content, meaning that yes, it has been successfully deleted. The next response code, anything beginning with a 3, is redirection. So for example, if you're browsing something on the internet, you'll see that you sometimes get redirected to a different page. That has been done with a 301 redirection response code. So those are good response codes. We can also have bad ones as well. So anything beginning with a 4 means that there's a client error. If you get a 400 response back, that means it was a bad request or malformed syntax in your request. A 401 is unauthorized. You didn't send the valid credentials. 403 would be forbidden. Again, this is likely you haven't sent the correct credentials. A 404 message, you've probably seen this before when you've been browsing the internet, means that the page is not being found. You've probably put in a typo in the URL there. 500 response messages means that it's a server error. Common one you would see here would be a 500 internal server error. So we've got the codes coming back with the responses. Responses to GET requests will typically include data in the body with the information that you requested, and headers can also be included in the response as well. Okay, so that was SOAP and RESTful APIs. In the next lecture, I'll cover the network-specific APIs of netconf, restconf, and gRPC. And then I'll give you a lab demo showing a RESTful API in action, how we can make those CRUD requests using the Postman